Welcome to today's webinar from Accendo Reliability. This is Fred Schenkelberg, and I'm going to talk about something that has dawned on me over the last couple of years, and I've talked about it on podcasts. That's probably why I started with that opening. And also as Carl and I have been putting together a book about how to, basically it was on reliability management, and we focus on how do you know what's the right thing to do? Just because you have a thermal chamber doesn't mean you should always use a thermal chamber for all circumstances. It's that analogy, if the only thing you have is a hammer, everything looks like a nail. But we focused in how is it that somebody with experience knows what to do and what not to do, what to focus on and what not to focus on. And that's really this point, is that when you look at how products get created and end up with the reliability performance they have, there's a whole series of decisions that are made that make that difference, that make it more or less reliable. And so that's what I wanted to talk about. It's a central piece to this book that we're working on, but it's also, I think, central in general, that we need to understand what it is that we're actually trying to accomplish. And so let's get into it. And if I can get my cursor over here. Now, reliability, and this is kind of preaching to the choir here, is that the reliability is defined a whole bunch of different ways, but essentially is that the product should work over time. And I like to tease my quality friends by saying that we do everything quality does, but we do it over time. And the idea is the color should stay the same, the feature set should stay the same or improve if possible. It should be maintainable if it's such a system, and so on. But the idea is that the product should work to do what it's supposed to do in its environment and so on. We have lots of various definitions of this, and engineering definition of it and a few others. But the idea is that we're trying to create a product that actually is reliable, is that it works over time. In many, many circumstances. Now, whether that's maintaining a production line in the equipment we got there, we want it to have uptime, not be down for repairs or maintenance, but reliable, that when we go to it, it will run for the shift, or we get in a car, it will make it to the store and back, but then also have a relatively minor cost of ownership over the life of the vehicle, however long we hang on to it. And so lots of ways we think about reliability, but how do we actually get there? And part of it is that we think about the performance of our product. And now customers think about the performance of our product in that it does something of use for them. It provides them value. They spend, say, $20 for a brush, and they are able to do calligraphy and do the writing that they want to do and create the artwork they want to do. That creates them multitudes or multiplication or multiples of that $20 of expense that they did, gives them much more value than what they spent for it. Customers buy our products by and large because they get value from it in one form or another. And it's the performance. Now, not everybody picks up on the exact same feature set of a product, which complicates the issue. If one person is really concerned about color and how the color fades, that's different from the performance person that buys a car just because they want it to accelerate quickly onto a freeway, for example. Whereas another person may want comfort or sound system is their criteria, primary thing. And those all may be auxiliary performance feature sets than it actually is just a vehicle to get you from point A to point B. And then I guess one of the hardest parts, and this really could be a whole nother podcast, is that customers change their minds. what at first they liked, maybe it was the sound system in their vehicle, but then over time, the seat's not comfortable. So then that feature set, which wasn't a concern early on, now becomes dominant, and they say it's failing. And so the feature sets, the performance of our products, and how those are interpreted are constantly in flux from the time we start the concept of a product all the way through to when it's finally retired by the end users and customers. And all along the way, there are decisions from, are we going to create this product and who's it for, all the way to, is this meeting my needs from a customer's point of view? And I have hesitated to put a number on the number of decisions, but it goes, and we'll dive into it in a bit more about the range of type of decisions that impact reliability, but there's lots and lots of them, right from the start. What are we trying to accomplish? All the way down to the final details of the torque on the last screw that you assemble the case with. Those are all decisions that at some point impact reliability. Well, William, I just saw your comment here. Most of the time, products and processes are designed, and then the reliability is assessed, and you sort of take what you get. You really need a well-defined reliability target. I really agree with that. Unfortunately, the sentiment of we get what we get is unfortunate. And that's been a central part of my career for years and years and years, I should say decades. And other reliability professionals I know and get to talk to quite a bit, is that, well, just getting a good target, a good reliability objective is a piece of this. But how do you translate that requirement saying we need to be 98% reliable over 2 years in our environment for our customers and for these feature sets? Having a good target is great. It's not enough, though. How is it that that target gets translated into impacting decisions? And how do we go about doing that? And how do we focus on that? Because just having a target, it could be a banner on the wall, so to speak, or it could influence every single decision that's made. But there's a bit of translation there, a bit of transference that occurs that makes these decisions actually change in order to achieve those objectives, those targets. Now, a lot of what you just said there, William, and it might be a whole nother podcast just about how organizations evolve into caring about achieving reliability, and setting a goal as a piece of that, but it's not enough. And we need to step away and look at, well, how do you actually achieve the reliability that eventually actually occurs? And so that's what this talk is today about. So before I dive into what I think are those decisions, with that brief introduction, what do you think? The chat window's open, and I believe it's working. What are the decisions that you see that occur within your organization that actually impact the reliability performance of your product or system or production that you're using or working in? And it gives me a chance to get a sip of water here. All right. Well, I'm not seeing anybody jumping in there to offer some, so maybe, there we go. Yeah, how do you define customer usage? Customer, schedule and budget. Yeah, definitely. Yeah, schedule. The schedule I see, I remember talking to a engineering director in a customer service division of a company, and when I asked her how do they set their priorities, she says, well, it's time to market, and time to market. That's all they care about. Budget and everything else, all the decisions were first considered to, can we ship it on time? And everything else was secondary. And of course, there were other limits, but the primary focus was schedule. And for some products in some markets, that's absolutely true. Well, other products, it's performance. You know, if you're creating a Formula One car, yes, there is a schedule, but you spend a lot of time and focus on the performance. Will it make the duration of the race at the highest possible speeds and all those kinds of things? Different requirements, let's see, safety, good. Yep, exactly. So all good types of decisions that go into it. And those are all pretty high level. So let's dive into this a little bit more. So in the design phase, from concept until we really are handing it off to production to start producing the product, and I'll use generic production life cycle here, where concept, design, and it goes out to get components and materials, and then it's assembled in the manufacturing process, and then it's transported out to customers, and the life cycle in that general sense. But everything from, well, what technology are we using? You know, are we doing a product that's an app? It's completely software and it relies on other devices to deliver it. What are those feature sets and compatibilities and so on? To like a phone, are we going to use this kind of material or that kind of material? I don't see too many phones made out of wood, but aluminum, and I imagine there's some out there with titanium in it. And the screens come with different material sets and capabilities and scratch resistance and all these other things. If I'm making a bicycle, the difference in a carbon composite frame versus an aluminum frame versus the old steel. I think I had a steel Huffy at one point in my life because it was really heavy for a small little bike that I had. But what material set am I using? What is the appropriate materials for the application I'm using? It may be obvious, or you may have a number of choices, but those are decisions that impact how well that product or system will respond to the environment that it's in, into the use conditions and the stresses that it sees. Now, I wear a pair of eyeglasses that, I mean, they're a long way away in technology and materials from the one I got in the Army way back when, which was a hard plastic and glass lenses, where I now have a polymer composite lens with a titanium frame. And the function is that it corrects my eyesight so I can read and drive and do things like that. But the weight and the comfort and the styling are all completely different than those old military clunkers I had way back when. But some of our choices in technology and materials is for where we want to position in the market. What is our performance criteria? So all of those kinds of decisions are generally made with some, maybe a little bit of reliability consideration in it. But if I had just bare metal steel or iron, and I'm putting it in an environment where it was a lot of salt and moisture and humidity and things like that, well, most designers obviously know that if rust is not a feature of their product, we need to coat that, or we need to do some other phenomena there, right? And all of these different trade-offs that we're trying to do, and William writing into that, is the idea is that even in those very early decisions that our design teams are making, our concepts are being created, often includes the consideration of reliability. You know, will this work in this environment? Will it meet these loads? Will it meet this requirements for wear and for tear and for maybe it's all aesthetics? Will it maintain its color and shape and texture? those are reliability decisions. And often at those very early stages of our products, the reliability professionals are often not involved. Yet, as many of you know, is those oftentimes become the boundaries of which we need to actually create a product that works, and are often the most important decisions that affect the eventual reliability performance of a product. Now, there's tons of trade-offs that go into those things, but realizing that those decisions are made not by us, but in trade-offs and other considerations, even before the product is drawn out or sketched out. It's just early concept things. Those are often the most important decisions. And there's tons of other things that happen after that, like setting up what is it this product is supposed to actually do? What is the requirements document that we often see that lists the color, the weight, the types of materials, the dimensions, all of those other elements that give us a clear definition of what it is we're trying to produce. You know, does it even have an on-off button? Does it have a certain texturing? Does it have rounded edges, or what kind of materials are we using? All of those things get defined, but those are decisions, right? And again, it's generally not done by the reliability engineer. You know, a car should have so much horsepower. Okay, well, that's going to dictate the size of the engine, the types of gearboxes, a whole pile of other things spin off from that early decision that are going to impact the reliability of the product, of that vehicle. But obviously, all of those things aren't considered as only reliability decisions, but they certainly have an impact on it. Now, later in the development process, and this is where we start to get involved as reliability professionals, is, well, which vendor should we choose? Which type of component should we use? What type of options do we have here for coatings on this material? Which vendor provides us, historically from our work with them, a more reliable feature set? Which one's causing us problems? For example, I ran into one organization that it was an aircraft company that was creating small aircraft, private planes, basically. And anytime something was removed from an aircraft, the FAA requires them to keep a log of it. So this company made it very easy for their owners to log stuff by giving them the computer and all the software and everything else they needed to make that a simple process. But once they got it recorded on that computer or on that system, the company that manufactured the aircraft would immediately get that information, and the vendor of, say, that navigation system that was pulled out of a plane would also get that information, and any notes that the maintenance or the owner made about why they were replacing it. And so they had really good field data. And so when they were speccing out a new aircraft for somebody, and they could pull up and say, all right, this plane is going to be flying based out of the southeast of the US, and given those particular conditions and the frequency of flying that this kind of aircraft gets in that region, this is the set of components from these specific vendors that do better. Whereas other components that are, say, jump planes or bush planes up in Alaska may benefit from a different selection of components and vendors. And they had the data to that fine a resolution to be able to say, no, we're going to go with vendor A versus vendor B. And here's the two Weibull plots that show the differences in this particular application or particular region of the world or different type of aircraft it is. It was pretty amazing the amount of information they had when they were outfitting and designing aircraft for their clients. But there again, a lot of times that there was a great amount of reliability information, and most engineering parts of that team understood and knew how to use that software to pull up, and their software would pull up multiple Weibull plots and overlays of vendor A, vendor B, for example, and given different conditions and so on. So they kind of integrated it across their organization. But most of us get involved, unfortunately, with components and vendors when something goes wrong, right? There's this part's failing, or this one's causing premature issues in the field, or this one's not able to be produced because out of spec. And quality and reliability folks tend to get tapped to go sort that out and fix it. And as you know, that's always after the fact. Why did we choose these people? Why didn't we understand how good or not good they were before we designed them into our product? Again, there's a lot of decisions that get made there that in some organizations, it's deliberately part of the reliability discussion. And it's in part of the material content of making that decision includes its impact on reliability. And in that other organizations, it's obviously not. But at all of these, and a couple of you have mentioned this, there's so many trade-offs that go into the design. And if you're under schedule constraints and you don't have a long development time, a lot of these decisions are made very quickly and with whatever information is available. Now, one of the things I've run into across so many different organizations, and we're working with so many different engineers and managers, is that people generally want to create a product that works. And a lot of those trade-offs are done based on their experience, their gut sense of what's going on, what they know about what's working or not working in the market, and what's working or not working with their particular customer set, if they have access to that information. And that's a key piece of this whole puzzle, is how do you help people make better decisions? And so just in design, there's literally thousands of decisions, from are we going to put Teflon coating on this to how should the button feel? Each one of those can make a difference of how a customer perceives the reliability of your product. Yeah, well, I haven't moved off of the screen yet, Yang. So let me see if I can move it off here. So manufacturing. When we get to assembly, and here part of it is the supply chain, and the decisions of which suppliers we're using is often made during the development process, the design and development process, but parts go out of, change, or companies go out of business, or they change locations, or parts are obsolete, or all kinds of things with the supply chain. And also, as many of you know, is once you go from, a handful of prototypes to hundreds or thousands of components, you start to see more variability. And so being able to create products, tolerance and quality control, exactly right, Brian. I have often leaned on, like at statistical process control and design of experiments, which I learned in a manufacturing setting as being critical reliability tools. And it's much, much easier to create a reliable product that when you have a stable process, in whether it's the process of the actual assembly and the steps that are taken and the tolerances that are maintained and monitored and checked and all of those kinds of things, to the process of how do you deal with changes? How do you deal when a part or a supplier changes, or a component or an issue gets redesigned? How do you go about making sure that that process also is stable and maintains your ability to create a reliable product at the end of the day? And so in the manufacturing process, and early on in my career, I worked for a company that had an end of quarter push, and it was to make their numbers. And at the time, I really had no concept what they were talking about, but it would be lots of overtime. The plants, all the various divisions and their facilities would be running full tilt, and engineers would be on the production line and all those kinds of things. And about 2 months later, as these particular products made during that last week of the quarter got to the field, they had like double the failure rate. as one person said, mistakes were made. And the rush to get products out the door was also met with a blind spot to errors and issues and problems. And, oh, I don't have that screw. Well, it'll work without it. And well, it won't. And it gets shipped. And it wasn't until there was a new CEO came in and said, stop it. We're not doing end of quarter anymore. We're here for the long term. We're here to make products that meet our customers' requirements. We're not driven by our sales quotas at the end of the quarter. We're here to actually fulfill the customer's expectations of a product that works. And it was a dramatic change across the organization, but it dramatically reduced the number of field failures that was just a cyclic quarterly phenomena that was occurring across the company. And it dawned on me that, if we don't have a good, clean, stable process to assemble and manufacture and assemble our products, we're just going to make our products worse. And I also learned is when designers would come down into the production floor and say, hey, I got this prototype, can you run it through the plant? If you pay very close attention to the production of a particular item, one item at a time, it's almost hand built. And part of the issue is that we didn't do that with every product. And so creating systems that made sure that our products were consistent and stable and so on really helped. And so part of it is, I agree with Brian, is tolerance and quality control, but it's also the culture around your organization. How do you judge whether you're stable or not? How do you judge if this is good or not? Who can shut down the line when something's not working? And I've seen organizations that anybody can shut the line down when something's not looking right, something's not behaving right, something's out of spec, for example, and it gets resolved. It's in other organizations, you just ship it, you make the numbers, and that's to the detriment. And that's a decision in that organization of how they operate and what they focus on. So again, a whole raft of decisions that are made, although including, and I don't have a slide for it, but including transportation. How do we box this thing up? How do we transport it? How do we understand how it gets installed? And all of those issues, all are decisions that we make that impact the reliability of the product. All right, now customers. I heard this, I don't know how many times over the years, but somebody mentioned it the other day in a message to me. We have all these fancy definitions of reliability and the 4 parts of function and duration and probability, environment, and so on. But at the end of the day, it's whatever the customer says it is. Right? If they say this isn't working, it's going to cost us money, right? And then we kind of grouse about the no trouble found. Well, it meets all the specs. Well, there's something not right about our set of specs if we're getting 25% of our products back, or it's our inability to recognize what the customer is saying is not right. Now, part of this is the customers are using your product to add value to whatever it is they're doing, right? They need this device or tool or system or product or feature set to accomplish something. And as I mentioned earlier, is some people care about the color, others will care about the texture, others will care about its performance, and in different ways and at different times in their use of your product. And so it's an ever-evolving, complex set of what it is the customers are deciding is working for them or not. And it's really their local situation. What is it that works for them to add value? Now, we attempt to understand what the customers need early in our design process and try to meet those needs. The hard part is that it's always moving. A competitor comes out with a feature set that they can't live without, and now your product's not good enough. It hasn't technically failed from a specification point of view, but it doesn't add the value they expect. And that's a failure. They will not buy your next product. They'll maybe even return the one they have if it's still under warranty, or they'll stop using it. But the final arbiter is the customers and the decisions they make as to whether this is working for them or not. And they make a lot of decisions. What one product might be working for the first week, but the second week it's not quite. And it may have nothing to do with the change in your product. It may have been the change in their criteria, right? So that gets complex. There's not a lot of things we can do about it, except understand that it occurs. And how do we influence those decisions? All right, this might be just a rhetorical question here, because I've said it about 15 times. We tend not to be the people making these decisions, right? So I don't know of any reliability professionals that truly have veto power for a product launch, right? Or what material set we're using. It's usually, a part of the equation. It's part of the information that's used to make these decisions is the reliability impact. And we may or may not be involved in those. And I will dare say that we are rarely involved with all of the decisions. And often we're not involved with a good number of the decisions that are made that impact reliability. And it goes back to that very early comment, I think by William, is like, well, they design it and then we get the reliability we get. It doesn't have to be that way, right? And there's a lot of things we can do about that. And part of that is how we influence decisions. How do we go about becoming a part of all of those decisions? All right. And so let's take a dive into that a little bit. We'll use the same structure here with design, manufacturing, and customers. What is it that we can do? And what is it that we typically do? Right. For everything from design reviews to the running variety of tests and doing research, all of those things are typical things we do. We build models, we gather information, we run evaluations, we plot field data, we do all kinds of cool stuff. And early on in my career, I was asked to design and run an accelerated life test. I didn't know why. I asked, why are we doing this? And it was a major customer needed to understand if this product had a good probability of lasting for 20 years. And I'm like, And this is one I often joke about. I thought, oh, great. I get to go to northern Italy, where they were going to use this particular product for 20 years to see if it actually works or not. And they said, no, we need an answer in 6 months. And so I was introduced to accelerated life testing. And there I had a direct connection to a decision by a customer, and which I'm getting ahead of myself a little bit on, but sometimes it's right in the design process. It's, do I use this material or this material? Which one allows us to achieve the reliability goal, the expectation of our customers that this, say, paint will maintain its color for 10 years or 20 years. How do we know? Which one do we use? And we might run a test for that and give them some feedback on that. But the types of information changes all the way through that design process, right? And part of it is that, we might create a, say, like a derating guideline for electrical engineers as they assemble and design their products. And in order to provide a set of boundaries for them based on our best practices so that they design in a reliable and robust set of components right from the start. Now, are the guidelines always accurate and the right thing that we need to be doing? Not really sure, right? It could be based on history, but as new technology comes in and so on, we need to keep up with it. Yeah, the various codes and requirements and techniques and best practices are out there that help us create stuff. I went to an architect once that I was taking out a load-bearing wall in the house, and the engineers, evaluated the circumstance and specified a particular beam, the size of beam and strength of this beam, and where it needed to be supported to replace that wall and maintain the roof over our head without the supporting wall that was originally designed. But they went to a set of tables to help them go through that engineering process to do it. We often go to models and different pieces of this, or we may pick up on, we need to pick vendor A or vendor B, which is most reliable. Or we often go into these things and say, that might be an issue. Let's make sure that in our evaluations and testing and looking at prototypes, we look at that particular ability of that failure mechanism to occur. And I know I've done that. I've walked in and looked at products and go, that sharp angle right there that's not supported for that circuit board is probably going to cause cracks. And the design team looks at me going, how do you know that? And he says, well, I've seen it a bunch of times. How's your product used? Well, it's portable, all right? You think it's going to get some vibration? Let's try it a few times. Vibrate it 2-3 times and that cracked right through. And some of it's experience, but most of it is, how do you extend that influence beyond you being in the room? That's the hard part, right? And the idea here is that the guides and reviews are examples of how we project how to think about these decisions. What kind of information you need? What types of questions should the design teams and the material scientists and everybody else, what kind of questions should they be asking? And that goes more to the culture of an organization. So if by example, and setting up policies and guidelines and ways reviews are conducted, that the proper questions are being asked and discussed that impact the reliability of the product, that's one way to create influence in the design team. The other part is doing a really good technical job of what we typically do, is running tests and evaluations and getting reports and looking for weaknesses in products and so on. That's part of it, but we can't be the only ones doing that. That has to be embedded across the organization. Yeah, and I'm looking at your question here, Brian, is that at the end of the day, product launch is a business decision. I totally agree. But part of that business decision is that, well, what's the impact? Are we there yet, right? If we're going to launch a product that's at a 20% defect rate, and we have some evidence to show that, what's the impact on that? If we were budgeting and expecting a 2% failure rate, is that acceptable from a business point of view? Now, of course, there are other considerations, right? If it's a consumer product and you might, if you're not on the shelf at a particular time, you just don't sell, right? If it's depending on your particular market, if you come out with a brand new jet ski right at the end of the summer season, well, it's not going to launch very well, and it'll be old by the next season comes around. Launch it 2 months late, you might have missed the market. And for some products and seasonal products in particular. But the idea is that if you don't know that it's going to have this massive failure rate, then you are making an uninformed or ill-informed decision. And that's my opinion on it. If it's fine, or we have evidence that it's most likely fine, well, that's another piece of the best possible information. I think that's what you're getting at, Brian. It's right. It's always a trade-off, which doesn't mitigate the need to have good information to make the right decision. And so part of this is figuring out what are those decisions that are being made and which ones are important. We'll get into that in a couple minutes. Manufacturing, again, I don't know how many plants I've walked into where they were measuring stuff and doing Six Sigma control charts and all the other good, happy stuff. And he says, why are you measuring that? He says, because we can. As it senses what they're telling me is what they said, we always measure that. Well, do you have problems with that? No. And it shows that we're perfect, right? Well, what's your first pass yield at the end of the line? Oh, it's only about 20%. All right. So you've got a measurement here that shows you're doing just great, but it's not related to the end of line testing that says you're doing really bad. Well, that's true, but we don't know what to measure. Well, are you working on that? No. We spend all our time measuring this and making it better. I'm like, okay, there's a problem here. Let's measure and monitor the items that we really need to get better information about. And that goes through all of our processes. Is right. What is it we focus on is usually the part that's going to get better, or the element that's going to get better. But just because it's good doesn't mean that we need to keep measuring it, or monitor it. We need those feedback mechanisms in some places, but if it's solid, if it's running great, move on, go find something else to work on, right? Don't set up all these evaluations and tests and just keep them forever. Regularly sit down across that manufacturing and supply chain and everything else we're doing to say, what is it we need to know? What is the information we need to have in order to make better decisions, in order to improve our process such that we make consistently reliable products, consistently products that meet our customers' expectations. And it's easy when it's connected to yield, right? Usually the stars align when you can make improvements to a manufacturing process and it improves yield, or first pass yield, especially. Then I don't have to do all these extra steps. And that almost always improves reliability. So I've gotten involved with manufacturing plants, realizing that the motivation is often throughput and first pass yield, in which encounters the cost of production. So oftentimes, instead of just saying, hey, we need to make it more reliable, is that, can we reduce the yield loss? Can we improve first time pass? Can we improve the throughput in a consistent manner? Those kinds of decisions are being made all the time in manufacturing, but it's often, unfortunately, what I see all too often is that we put in some measurement systems because we have that equipment. We know how to measure that thing, independent of why we're measuring that. What useful information what information do we need from that measurement system to make decisions? Is it serving the decisions that we really need to make? And so the influence here is often stepping back, saying, are we measuring the right things? Are we monitoring the right things? Are we evaluating and checking the appropriate things? One of the biggest parts is failure analysis. If the process that your organization uses is isolate the part that's failed and send it back to the vendor, well, that's a decision you can make, right? And you almost never, I would say very rarely, get useful and timely information that way. Now, of course, there are vendors and suppliers that do a great job. They're far and few between, in my experience. Instead, if you need to know that information of why this is failing so you can make improvements, invest in actually doing a good failure analysis. Again, that's a subject for a whole nother podcast, but it's one of the things that we often overlook as a decision. And yet, when we instantly blame a supplier for problems, that's a decision we're making. And we need to change that process to what's the information we need so we can make better decisions of how to move forward. That's a change in culture as much as anything. Right? Customers talk to us all the time, right? It's what they do. They either are very quiet and very happy and tell their friends to go buy your product and do all those things, which is great. Love seeing positive reviews, all of that good stuff. But we also hear about problems or complaints or issues. Like, I remember years ago, the CEO at HP said, why do we have we have 1,000 product lines and we have 957 different ways to locate the power switch. So sometimes it's in the front, sometimes it's in the back, sometimes it's a lever, sometimes it's a button. We had every permutation of how to turn on and off a computer and a printer. She said, stop it. She said, just why do we have to re-engineer a power on button for consumer products and business products? Let's standardize this and move on. Let's focus on the things that are important for the functionality of our product. And it's not the industrial design of the on-off switch. Come on, guys, make it consistent so that it's as consistent as the label we're putting on the outside of the box. But customers tell us, like, they'll call and say, where is the power button? How do I turn this thing on? Others are we can look at repair centers. If they're doing a good job, not doing shotgun repairs, we get a good idea of what components are being swapped out or replaced or tuned or whatever to bring a product back into service, but also good field data analysis. All of these are hints into what are the problems the customers are identifying. And we spend time in all three of these areas, more or less, depending on your organization. And it's the idea of looking in the rearview mirror, though, because the customers already have it and they're having those problems. And we're getting feedback that goes back to our design. And usually that's used for many products in the design of the next one. In some cases, you have a long tail on a production, and you'll end up improving the existing product. Or if there's a major problem, you have to fix it. Otherwise, it's subject to recalls and all those kinds of things. But how do we influence customers and the decisions that they make? Well, part of it is the setting the expectations with the customers of what this product will do and do for them, how it will create value. And some of that is in the marketing. A few years ago, I remember as cell phones have had a long-standing problem with moisture, right? If you get your phone wet, it's most likely going to fail pretty quickly. And so the advent of moisture-resistant phones and the commercials where people walking through the house pouring a bottle of champagne on it to illustrate its moisture resilience, set the expectation that they were waterproof, which wasn't exactly what the product was. It was resistant. So if you had wet hands, or you pulled your phone out while it was raining, or you set it down on a wet countertop, it would be okay, right? But you drop it into 15 feet in the pool and come get it after 2 or 3 weeks, it's probably not okay, kind of thing. So it really even though many people don't think of marketing as a reliability issue, it is, right? Where do you use this product? How do you use this product? How is it conveyed in the product advertising and literature? So what are the claims they're making? What is the expectation being established? Those are ways that we influence customers and how they eventually judge the particular product. And that's always a dance. It's beyond most of what reliability people do. Yet sitting down and talking to the marketing folks and the people that are going to be advertising our products as to what it is they're trying to convey and how realistic is that with what we know about how the product will perform. And this is part where it's well worth walking down that aisle. Usually they have much better coffee. But it's also a place where you can have dramatic influence on how the customers perceive your product. And it's in the marketing team's best interest that customers are set up with expectations that the product can actually deliver on. The satisfaction that is generated by that generally means more sales and more goodwill and word of mouth. That's not an obvious way to create value from reliability for most of us. Almost everybody I work with wants to do reduce failure rate. Well, that's only part of the equation. If the customer's happy with your product as it is, that's usually much more powerful than if they experience a failure. Right. So don't forget that we can and should influence customers. And some of that is not always obvious. Right. Plenty of examples. But here's the hard part. Up to now, I've only added to the list of the range of decisions that we're likely to experience in the creation of a product. Everything from what material we use to how a customer is establishing their expectations of what the product should do. That is thousands and thousands of decisions. Everything from what's the type of product and market we're going to where are we going to locate the power switch. Now, with all of those decisions, we are not going to be involved with every one of them, not by a long shot. But which ones do we need to influence? Which ones need information that will have an impact on helping whoever's making that decision make a decision that understands and weighs the impact on reliability appropriately? It's all in that trade-off with all the other criteria that we have to deal with. The hard part is sometimes we just don't know. We don't know that locating a screw hole on a circuit board can have major damage to the performance of that board. If we torque it down just a little too much, it can damage and short circuit that board, create a latent defect that shows up later and kills every one of them. And that's from experience. I know about this. But that's such a minor decision as to, do I put this hole a millimeter here or 2 millimeters off that way, can make a big difference in some circumstances. Setting up guidelines to cover every one of those decisions is not practical. But setting up the basics that identify those boundaries when we need to talk about it, when it helps people across the organization, especially when you're not in the room, say, we need to dig into this one a little bit more. We need to think this one through. I may need more information. Hey, reliability people, can you weigh in on this one? If your team is coming to you to say, hey, I need some information or I need some input, and it could be small decisions that seem inconsequential in the long range of things, or major decisions of which vendor to use for some coating you're putting on a product. If they're not asking those questions, where are they getting their information? Right? Now, they may all be well-versed and well-trained and understand lots of ramifications of their decisions on reliability, but that's not been my experience. Many care about reliability, but don't have the background and time to investigate everything they would like to. So part of this is looking at this long list of decisions, potential decisions, and which ones would benefit the most with better information, with appropriate information. For example, that accelerated life test I was originally asked to way back when to do, it was for a customer to decide whether to use our product or not. And it was a major project. So we invested the time to actually identify what is the answer to this question. And we had a timeline to do it, unfortunately, not 20 years in the Northern Italian Alps, but we had enough time to do a test, which the customer was a part of, and they agreed with the results and they ended up buying the products, which was great. But so many other decisions could benefit with just a little bit of information and a culture of saying, well, what is the reliability impact here? Sometimes that's the biggest piece we can do. The first step is identify them. What are all these types of decisions, and what are examples of how they connect to the reliability, the performance of our product? And then after that, it's to prioritize them. And we do FMEAs, and we do reviews, and we do all these things. I often use this term red flags, where it's what's new. It's a new vendor, a new environment, new procedure, new material set. What do we know about it? What don't we know about it? I like to ask, and most designers don't like it, is, well, how will this fail? Well, we're using this because it shouldn't fail. All right. Let's focus on that should part. How do we know? What are the elements that is unknown that more information from a reliability professional will help you understand whether this is the right decision or not? And so one way to prioritize these things is to look at, well, how important is it? Is this critical? If this doesn't work as we expect for, say, the 10 years or whatever our portion to reliability is for this element of a product, if it doesn't work, the product's a failure. It won't make business sense to do. That would be very important. Is it inconsequential in under nearly all circumstances? Well, that's not as important. Let's do our best guess and move on. For the important ones, how difficult is it to get the information? If we didn't have the technology of accelerated testing, and it would actually take 20 years of watching products perform in the environment, well, that's kind of difficult to do if we want to make a decision in 6 months. But using accelerated life testing is not trivial either. You have to design the test appropriately and all those, and there's some risks with it. But it's different than if the answer is just a material property we could look up in a book, which would be not very difficult at all. If we can point to existing information and resources that say, if you move this 5 millimeters away, the chance of the bending moment of a screw torque is not going to cause this ceramic capacitor to break. Well, then just make it 5 millimeters. And if you have to come inside of that, let's weigh the risks. So some of the gathering the information can be very difficult and very expensive. And sometimes it's trivial. So those are two vectors we can use to prioritize what we want to work on. Let's get the most important ones first, especially the ones that have easy methods to get the information required. Let's knock those out and influence as many of those decisions as we can. For the important ones that are difficult, well, that takes a bit of planning and resources. And a business decision, is it worth doing? And that gets more complicated. But if it's not important and very difficult to do, let's skip that one. Let's move on. Let's monitor if there's any outside risks there, but it's usually something that we're just never going to get to. And so we have to prioritize and then focus on getting the information for the ones that make a difference. And finally, we need to focus in on not that we're going to run an accelerated life test, or we're going to run an ongoing reliability program, or that we're going to implement a measurement system and monitor for stability in a production line. We need to understand what information we need and who needs it and in what format, so that they can consider that information as they make a decision. Sometimes it's like that accelerated life test. It was a partnership with this customer, and we ran the test. They saw it develop. They helped with the design of it, made sure that it was going to meet their needs. We ran the test, did the analysis, and they made their decision. Now, if we would have just said, oh, trust this, it'll work, they probably would have moved on and gone somewhere else. The piece of information they needed was some evidence that it would work for them to make a business decision to install our product. We don't always have it that clear cut. So by working closely with all of your stakeholders in your product, from management teams to designers to production floor folks to your suppliers, all the way across the board, including marketing, including finance, what is it they need in order for them to do their job better? What information do they need such that they can make better decisions considering reliability? I know I've told this story before, but at one point I was called in to talk to a finance person that didn't know how to interpret a Weibull plot. They had this great time to failure distribution information on a Weibull plot, but they didn't know what it meant. And so they misinterpreted it. And the information, even though it was there, was not understood. So a short meeting with that person to go through how to read these things and what it means and how to interpret it immediately changed the nature of the decisions they were making. And it's that part, is that just because you create the report, it's part of it is our ability to influence these decisions. Is it the information they can interpret? The person making the decision has to understand it. And oftentimes as engineers, we miss that part. It's obvious to us, but it's not obvious to the people we're working with. So obviously more I can talk about on that one. So how do we maintain focus and not jump on the latest, greatest, most recent failure or disaster? What's important? What's the critical pieces of information that influence the dominant or biggest impacts to the reliability of a product? That sounds easy, right? But when you get into the fray of it, you're going to have lots and lots to do. I think everybody here knows that. So part of it is by setting up that prioritization rubric, working with your team to help understand, do you need to, create guidelines? Do you need to run tests? What is it you need to do to create information that is of most value to your organization? And at that point, it becomes a plug for the book that Carl and I are working on, which talks about this process in detail. Long memory of disasters. William, one of my favorite things to do when visiting a site is we're sitting down to lunch someplace and I say, so what disasters have you guys had? Reliability disasters. And usually they can think of 2 or 3 of them immediately. And if you go back a year later or 2 years later, maybe 1 or 2 of the same disasters is still on that list. But people will remember the most recent 3 is my supposition here, or my observation, I should say. And there are techniques to extend that, to have a longer memory of it and institutionalize that into an organization. And I do think I have a webinar on that called Golden Nuggets. And if I remember, I'll put a link to that. Yeah, recency bias. Well said, Sean. So let me see if there's any, quality gone bad. So with that, I'll wrap up for today and I'll hang on the line here. I know we're at the top of the hour. I appreciate everybody spending some time here and participating. Chat window is going there. I'll have to scroll back a little bit here, see what else is there. If you've got a question, go ahead and ask it. I'll stay on the line and see, make sure that we cover everything. And I should have the recording up if you know anybody that would benefit from viewing the webinar in its recorded state. I should have it up in a couple of days. And with that, thanks everybody once again, and have a great rest of your Tuesday.